Hi everyone, thank you for being here. I changed a little bit the title, but I preserved the general idea. And what we were thinking about is how much renewables, or up to what point of renewable capacity we should install to reduce up to the maximum possible with tolerable cost the fossil-free generation. We take as a baseline scenario the two pre-pandemic years, so we don't have the distortion of pandemic, the war, and etc. But in this case, we have regularized the installed capacity of the whole year, because particularly the photovoltaic in this period in Spain basically doubles. So we have first of all apply a proportional ratio, a multi-proportional ratio, to assume that the total generation, the total capacity of renewables are the same during the whole period. And then we produce different simulations. This is the total distribution of the different technologies. This is based in the available public data of the TSO of the Spanish system, with a 10-minute sampling ratio. So, and it's the same for all the technologies. Then, what we try to see is, first of all, the wind power is also quite well developed in Spain, but there is like a lack of installed capacity of PV, at least in these years, because right now it's like a boost in the total capacity, but in January of 2018, it was like 4.5 gigawatts in total in Spain, which, like, knowing the capacity and the weather condition is like a madness, but not a technical issue, but a political issue that has been solved in the recent years. But anyway, the first we made was applying, assuming different installed capacity of PV, and keep all the rest of the conditions of the system variable. And of course, because of the hourly distribution of the power, there is a point in which it doesn't matter how much installed capacity we put, we cannot reduce the fossil fuel generation, because the fossil fuel generation basically with hydro technology are the one that follows the flexible, the variable of the demand curve. So of course at night we can replace with photovoltaics. And that's why there is basically an horizontal asymptote, of course, and basically the point beyond it doesn't work to put more photovoltaic, just considering this simple logic of increasing the photovoltaic capacity to reduce fossil fuel generation. We do this every single step of the 10-minute 2-year data, and of course, if there is more generation, we must curtail the generation. So the blue line dashes are the losses that we will incur by limiting the generation, and the red one is the total participation of fossil fuel generation for the predefined installed capacity. We repeat the same exercise with playing with the capacity of wind and PV technology, and of course, because the distribution of the wind resource is more flat, more homogeneous annually, at least in hourly basis, and they complement well in seasonally and daily nightly periods. So a further reduction with less losses can be achieved. For example, they are the points initial point of the data and the last point before sending the paper for the conference. Again, the dashed lines are the losses, and the straight lines are the participation of fossil fuel reduction, taking into account the logic I explained before. But what if we add a new degree of freedom, which is playing with the flexibility that brings hydropower? So the logic is if there is the sum of PV and wind is higher than the fossil fuel generation, we reduce the fossil fuel generation to zero. If not, we try to compensate with hydropower. If the required hydropower is too high or the derivative is too high, we of course do up to these limits, and the remaining fossil fuel generation will be reduced up to this point, which is quite low. But of course, this do not take into account the fact that it will require a lot of water for some installed capacity, and we take into account this by assuming an implicit storage that will be the energy storage that will be produced by the fact that in some instance we reduce the hydro generation, in others we increase to keep the fossil fuel generation as low as possible. And so the solution, the scenarios that are viable in terms of following this logic are the ones which are here in the dash frame of this scenario, of these plots. These plots basically extract two issues of this implicit storage, which are the integration of the difference of the supposedly hydro profile with the original data. So the integration give us an idea of if we are using more or less water, so the water will remain in the dams and will not flush. So if at the beginning of the period, at the end of the period, the difference is not so high, it means that we basically use the same amount of water. If it is too high or too low, it means that we use too much or too low or too much water. This point here is very interesting because is the one that, or one of those that with the same amount of water used for power generation reduce up to less than 1% the fossil fuel generation. Okay, produce this kind of profile, but of course we must take into account another variable like energy storage and congestions and primary and secondary reserves and so on. But this is just like the limit, the ideal, or we must get as close as possible. Then yes, this point is very interesting because the analysis of the Spanish TSO, basically for the scenario 2026, give more or less exactly this configuration of installed capacity of wind and PV power. So with this scenario, with this considered by the TSO, we could, if there is the desire to, basically reduce to insignificant values the fossil fuel generation, but this is of course a matter of political willing, and of course take it not thinking into the make profits, but into the reduce the total environmental impact of the national generation.
Thank you. Thank you. separately the PV and wind generators, but in fact the hybrid installation in order to reduce all the fuel generation, in order to match the demand and the generation in the districts.
When you say hybrid generation, you mean?
Consider PV plant and wind generation
At the same time.
at the same.
Yes, yes, probably I do not explain it well, but this is a scenario. So at the same time, for different hypothetical installed capacities.
It's not a separate generation, but it's the
Yes, it's taking as the whole renewables. Yes.
In order to check with another kind of demand.
No, we assume that the demand is exactly as it was.
Okay.
So we try to match instantaneously the power varying renewables and fossil generation. Just PV, then PV and wind power, and the third step was PV, wind, and hydro. And another step would be taking into account reversible hydro power stations and energy storage systems like batteries and so on.
Thank you very much.